So, having seen sorting and hashing, having compared their cost models, having seen that both of them are parallelizable, which one is better? Well, at the highest level in the simplest analysis, we saw from the memory and I/O behaviors that they have the same memory requirements for two passes, the same I/O cost, okay? And so therefore they're pretty much dual. They're the same, they just have some different behavior ordering. But we can dig a bit deeper and then we can find some alternatives here where sometimes sorting might look better and sometimes hashing might look better. One of the pros of hashing that we just saw was that it's really nice for shuffling data equally in the parallel setting. We don't have to worry about data skew quite as much with hash functions as we might in trying to pick the split keys for sorting, which is quite tricky. Another advantage of hashing is a bit more subtle. Let me explain it in the case of duplicate elimination, which is where it most frequently arises. And what I'm going to argue is that hashing scales with the number of distinct values in your input rather than the number of rows in your input. So you can have many, many rows, but if it's got few distinct values, then hashing will remain cheap. So let's look at this. In the second phase of hashing, when we're doing the construction of the in-memory hash table for a partition, even if that partition was very long after the first phase, suppose that you had few distinct values in it. So as we're building that in-memory hash table, let's say we see a 3. We put that 3 into the hash table. The next 3 that we see, when we go to put it in the hash table, we recognize there's already a 3 there, and we simply delete that second 3, or third 3, or fourth 3. We don't store it in the hash table, which means that that in-memory hash table in the second pass, when we're partitioning on H sub r, is going to have buckets where there's only one entry for every distinct value. So even if the data is enormous, has billions of rows, if it has a small number of values, in the second phase, those very long runs from the first phase will boil down to very small hash tables in memory. And so that main memory hash table scales with the number of distinct values, not with the number of rows in the data. And compare that to sort. With sorting, there's no such optimization. Sorting will simply sort all the records, and therefore it scales with the number of records, as you would expect. Hashing has this nice property that it scales with the number of values. Sorting itself also has pros, of course. The first is when we need to have the output sorted for some reason. So clearly then we have to use sorting. Hashing's not going to sort for us, and our only option is to do sort. Another advantage of sorting is we don't have to have a special case for handling duplicate values. If we have lots and lots of duplicates in sorting, we don't care. We simply sort the values and off we go, certainly on a single node. So that's an advantage of sorting. It's not sensitive to duplicates quite in the way that hashing is.